Have you ever wondered exactly how JavaScript works in your browser? Let's unravel the mystery. JavaScript, a high-level, interpreted programming language, is the third pillar of web development, alongside HTML and CSS. It breathes life into your static web pages by making them interactive. But how does it do that? Well, it all happens in your browser, where JavaScript is parsed, compiled, and executed. By the end of this video, you'll have a solid understanding of how JavaScript works in your browser. So, the first thing to understand is the JavaScript engine. This is an essential player in our web browsing experience. It's kind of like a translator, taking the JavaScript code that developers write and converting it into something the computer's processor can understand. You can think of it as a bridge between the language of the web and the language of your computer. Now, it's important to know that every browser has its own version of a JavaScript engine. Google Chrome, for example, uses what's known as the V8 engine. Firefox uses SpiderMonkey, and Safari uses JavaScript Core. Each of these engines has its unique features and performance characteristics, but they all do essentially the same job. They take your JavaScript code and turn it into low-level or machine code that your computer can run. These engines work in a fascinating way. They read the JavaScript code line by line and compile it into machine code. This process happens so quickly that you don't even notice it as a user, but it's an integral part of how the web works. But why is this important? Well, understanding how the JavaScript engine works can help you write more efficient code. It can help you understand why some code runs faster than others and how to optimize your code for better performance. Remember, the JavaScript engine's job is to process your JavaScript code so your computer can understand it. Next up, let's talk about the execution context and the call stack. To understand this, imagine a stage where a script is being performed. The execution context is like that stage. It's the environment in which the JavaScript code is performed, and it holds all the necessary information for the code to run properly. When JavaScript runs the code, it creates a global execution context, kind of like setting up the stage for the performance. This is the base environment in which the code starts running. But here's the thing. JavaScript is a single-threaded language, meaning it can only do one thing at a time. So how does it handle multiple functions or tasks? Enter the call stack. Think of the call stack as the director of our stage play. It keeps track of all the scenes, knowing exactly which one is currently being performed and what comes next. In JavaScript, every time a function is called, a new execution context is created and pushed onto the call stack. This new context becomes the active context. When the function finishes, the context is popped off the stack and control returns to the context below it. So the execution context and call stack work together to keep track of where we are in our code. Finally, we have the event loop and the Microtask queue. These are the unsung heroes of JavaScript, silently managing the orchestration of asynchronous operations. Imagine a conductor of a grand symphony, where the notes are your JavaScript functions. The conductor ensures each note is played at the right time in the correct sequence. That's exactly what the event loop does with your JavaScript functions. The event loop is like a vigilant sentinel, constantly monitoring the call stack. It patiently waits until the call stack is empty, and when it is, it takes action. But where does it get the functions to add to the call stack? That's where the Microtask queue comes into play. The Microtask queue is a waiting area for functions that are ready to be executed, but are waiting their turn. As soon as the event loop sees that the call stack is empty, it immediately takes the first function from the Microtask queue and places it onto the call stack to be executed. This process continues in a loop, hence the name, event loop. This elegant dance between the event loop and Microtask queue is what enables JavaScript to handle asynchronous operations. It allows JavaScript to perform non-blocking operations, meaning it can do multiple things at once without having to wait for one task to complete before starting another. So the event loop and Microtask queue are what make JavaScript asynchronous, non-blocking operations. And there you have it. We've journeyed through how the JavaScript engine processes code, how the execution context and call stack track our code's progress, and how the event loop and microtask queue manage asynchrony. Now you have a basic understanding of how JavaScript works in your browser. Keep exploring and happy coding.